of the static friction is 1.2, and the coefficient of the kinetic friction is 0.85 between the tire and the road. What is the maximum speed at which the car can negotiate the curve with the constant speed? Okay. So what happens is that if you look at this problem from the top, okay, so you have a circular curve like that, and the car, okay, you have car here, and so if you go with part of the circular motion, okay, as part of the circular motion. And then what we have to do, we want to determine the maximum speed at which the car can negotiate. How can we find the maximum speed? For the circular motion, speed is related to the centripetal acceleration. Okay. AC equals to v squared over r. So to find the maximum velocity, that means we have to find the maximum possible centripetal acceleration can be provided in this case. Okay. Now let's see why we have some maximum possible value for the centripetal acceleration. So in this case, the first thing you need to identify which force is providing the centripetal acceleration in this case. You must have some force here, right? Some unknown force here to provide the centripetal acceleration. Otherwise, it wouldn't go along the curve. Okay, which force? What kind of force?
Acceleration.
Acceleration is not force. Which force provides the acceleration?
Oh, friction, yeah.
Okay, friction. Okay, it's a friction to provide the centripetal acceleration. You can know that sometimes we go through a ramp if there is not enough friction. For example, in a rainy day, you may have side sliding like that because you don't have enough friction. So that's a friction to keep you move along the curve. And now we understand this is the frictional force, but you can check. I'm giving you both the kinetic friction coefficients and the static coefficients. So, but I didn't tell you if this is a static friction or kinetic friction. I kind of let you to choose. So, are you going to choose static or kinetic friction?
Static. Static.
How many of you will choose static? How many of you will choose kinetic? Okay, kinetic is a bit more, and that's understandable because you think that the car is in motion. But the right answer is this force is static frictional force. Okay. And the reason is that, think about, at this point, what is the direction of the velocity? In this curve on top, if this is the velocity, right? Then the kinetic friction has to be against that direction. So where is the kinetic friction?
Downward.
Okay, so this is the kinetic friction. It's the frictional force trying to slow the car down. It's not the frictional force along this direction. So usually both in this case you have both the static frictional force and the kinetic frictional force. And why there is a static frictional force? Because without the static frictional force, the car has a tendency to side slide, right? So it has a tendency to this direction. So in that case, to prevent it go this way, it has to apply some, you have to apply some static frictional force. So that's an interesting thing. The car has some actual motion along this direction, and at the same time, the car has some tendency of the motion in this direction, but it can never really realize this tendency due to the static friction. Okay? Any question here? So now, if you determine this is static frictional, you can understand why there is a maximum velocity. Because static frictional force has a maximum value. So then, that means when the static frictional force provide the centripetal expression. The centripetal acceleration will have a maximum value, and then the velocity will have a maximum value. So we just need to calculate the maximum centripetal acceleration. So that means it happens when Fs equals to Fs max, right? So Fs max can be calculated as equals to mu n, mu Sn. Okay, so here mu S equals to 1.2. N is the normal force. And to calculate the normal force, if we look at this from the back or the front, okay, then you have some upward normal force, you have some downward the weight, and this is the static frictional force if you look at from this direction. So this is our positive x or c direction. This is our positive y direction. Okay. So we are going to get Fs along x direction. The only force will make MAC, right? And along y direction, n minus mg equals to 0. Acceleration along this direction equals to 0. Okay. So here I skipped a few steps, but so I think we should be comfortable with that, right? We already solved a lot of problems like that. And so V equals to square root of mu SGR. If you substitute number, you get 1.2 multiplied by 9.8 multiplied by, what's the radius?
50.
50, okay. Quite a small circle. And equals to something in meters per second. That will finish this problem. Do you have any question here?